the prep, or?
Yeah. Let's just go over the prep 1 through 3. Begin by reviewing the product of sum the product identities. Notice that you do not have any of these memorized. Or notice that you do not have to have these memorized or even recommend that you memorize them. The power reducing identities are heavily in calculus, so we provide them for your convenience. Okay, perfect. So rewrite the following expression. Let's see. Rewrite the following expressions using either product of sum or sum to product identities. Simplify if possible.
And that the cos A, cosine A, cosine B is equal to half, parentheses, cosine A plus B plus cosine A minus B. Like that? Is that what she's talking about?
Yeah, exactly. Yeah, so on the key, so yeah, so you had that right. So it would be half, and then it would be cosine of A plus B. So it would be, half of B minus, or the absolute value of A minus B, which would be cosine of 5 degrees. And then plus the cosine of A plus B, which would be 73 degrees. Yeah, good. And then sine, isn't that just 2? What's?
Crap, well, there's two different ones. There's half, well, if we made the cosine. Yeah, it's just the same thing, sine of A plus B plus sine of A minus B.
Okay, so it would be what? Half sine of 8x plus sine of 2x.
Oh, it's the absolute value?
Yeah.
Okay.
And then I think you can simplify those within the parentheses, so then it turns out to be half sine 4x, and then x, sine plus sine of x.
So it'd be half sine of 4x?
Or
would it be 16x?
It would be 2 sine 4x plus sine of x.
Oh, gotcha. Gotcha.
Yeah, because we're dividing by 2. So half divided by 2 is 2. Or what? Wait, what?
I was say I have no idea what you're doing right now. It'll just be sine to the power 2, 4x.
Oh yeah, sorry. So you divide that whole thing by
sine to the power 2
by
x.
Yeah.
Okay. There we go.
Okay, and then on number 3, find the exact values by either using product or sum. Sum to product. Okay.
I'm sorry.
I have no idea what this is. I have no idea.
All right, I'm back and this crap is busted. I hate it. But sorry, what I was saying is for number 2, the second one. So I don't know how that works because it's sine of 3x plus sine of 5x, not sine times the sine.
Doesn't addition go to multiplication, and doesn't subtraction go to division? And so up top where it was multiplying, you add them, and because down low you're adding them, you multiply them.
So it looks like for sine A plus sine B, I just Googled product and sum formulas.
Yeah.
But it looks like it's actually 2 sine parentheses A plus B over 2. And
A plus
then
B over 2. Okay.
And then cosine A minus B over 2.
Oh, that makes total sense. Yeah.
So
does that make sense to you?
No, really.
Okay. So if you look at it, so it's always going to be 2 sine, right? Because that's just the coefficient. Okay. And then it's going to be 2 times A over 2. Or wait, what was it?
A plus B divided by 2.
Yeah, A plus B divided by 2. So it'd be A, which is 3x plus 5x is 8x.
Divided by 2 is 4x.
Yeah. Which is 4x, and then what was the second one?
Cosine of A minus B over 2.
Yeah, so A is 3x, and then B is 5x, but it's always going to be an absolute value. So it's going to be negative 2x, which is 2x over 2, which is just x.
Okay.
So then
I see how to solve it, but I don't understand why it works.
Yeah, I think the reason why it works is just because you have to plug it into that formula, and you just have to know what that formula is.
Okay. I can live with that.
So, yeah, I mean, I think that's as good as we're going to get it.
All right. So then for this one, so we got sine of 13 pi over 24 cosine of 5 pi over 24 is equal to, so that's going to be a half, parentheses, sine of A plus B, so that'll be
18 pi over
24, which would be, what is that, 3 over 4.
Plus A minus B?
Sorry, it's plus sine of A minus B.
Which is going to be pi over 3. And then sine so it'd be, what's sine of 3 pi over 4 plus sine pi over 3? 3 pi over 4 plus pi over 3 is
square root of 2 over 2? The radical 2 over 2?
How'd you get that?
Unit circle?
So you just looked at the sine at 3 pi over 4?
Uh-huh.
And what was that?
That's radical 2 over 2.
And then what's the sine at pi over 3?
Radical 3 over 2.
Okay, yeah. So it would be the sine. So the sine of 3 pi over 4 is 2 over radical 2.
Radical 2 over 2. And then.
Oh, okay, yeah. Radical 2 over 2.
So it'd be half times radical 2 plus radical 3 over 2. So it'd be, that whole thing would be radical 2 plus radical 3 over 4, right?
It would be 1 over 2 radical 2. plus radical 3 over 4. Yeah.
Wait, what?
1 over 2 radical 2 plus radical 3 over 4.
Well, it's hold on. So sine of 3 pi over 4 is radical 2 over 2.
Yeah.
And sine of pi over 3 is radical 3 over 2. Okay.
Yeah.
So
Yeah.
add those together and you get radical 2 plus radical 3 over 2, right?
Radical 2 plus radical 3 over 2. Yeah, and then I think you have to times it by a half.
So that would make it radical 2 plus radical 3 over 4, right? Because you're timesing the whole top by 1 and the bottom by 2.
Yeah, so we got the radical 3 over 4 right, but I'm just confused on why, because I just looked at the key,
Okay.
and she has 1 over 2 radical 2. I don't know why she has it over.
Well, that doesn't make any sense. I'll be honest.
Because the radical 3 over 4 makes sense.
Mm-hmm.
But I don't know.
Where's the key button? There. Or even where. Oh, I looked at the wrong one. No, not. Yeah, I don't know. That doesn't make sense to me.
Should we move on and I'll make a note to ask her a question on that one?
Yeah.
Okay. Prep 3, 1. Okay. And then,
Yeah.
so the sine at 75 degrees is, let's see.
All right, so we got sine of 75 plus sine of 15. All right, let's be real. That's going to be 1. If I had to guess.
Why?
No, well, yeah, maybe not. Just because 75 and 15 is 90 and sine of 90 is 1. But it's not quite how it works. So.
Right.
All right, so
we need
we've got
that formula.
2 sine
Yeah.
90 over 2, which would be 45.
2 sine of 45. Cosine of what?
Cosine of 60 over 2, so 30.
Yeah. And then what's the sine at 45? Let's see. Unit circle. The sine of 45 is
Pi over 4. Sorry, radical. Yeah.
radical 2 over 2.
Uh-huh.
And then cosine at 30 is square root of 3 over 2. And so then the square root of 2 times the square root of 3 is 6, right? Square root of 6 over 2. Yep, and that's the answer.
I'm sorry, say that last again.
So it's 2 sine 45 cosine 3, right?
Cosine 30, right?
Yeah, cosine 30, sorry.
Okay.
And then, so it
becomes
the sine of
radical 2 over 2 times radical 3 over 2, right?
which comes out to be radical 6 over 2.
But hold on, we don't. Does it say? I don't remember the whole thing being in parentheses. It's because it's not. But so how does that become radical 3 over 2 then? Or sorry, radical 6 over, oh, that's the or. Why are there two different answers?
I think that's just the simplified answer. It's the square root of 3/2.
Oh, okay.
And then you just simplified it to square root of 6 over 2. All right. Time to do the...
Got it. I see it now.
Yeah. All right. Time to do the what's it called?
Other thing.
The extension problems.
There we go.
Okay. Spend time discussing question 5 about solving. What does it mean to solve? What are you looking at? Okay. So looking at question 5 on the prep problems.
Team discussion. All right.
So the sign of that is 1/2. And then
So it'd be, to solve for A, it'd be the inverse of sine of half.
Yeah.
Equal to A.
Yeah, but we can't use a calculator, and that's where it's tripping me up.
Okay, well, why don't we use the unit circle?
Oh. Yeah, so the sine of 1/2. Wait.
It'd be 30 degrees, right? So
30 degrees, yeah. So
radical over 6.
11 pi over 6. No. Pi over 6 and 5 pi over 6.
Yep.
How'd they get that?
It'd be pi over 6, right?
X and oh, okay. We're not going 360. We're only going 180. So it's pi over 6 and 5 pi over 6.
Okay.
Okay, and
But then how do we get the inverse for that now that we've...
that is the inverse.
So 5 pi over 6 then?
Yeah, pi over 6 and 5
Okay.
pi over 6. So then -1 square root of 3. So we have to find where the tangent is -1 over square root of 3.
Nowhere?
It's at I think it's at square root of 3 divided by 2 times. I don't know.
Yeah, I don't either.
I'll ask her on that one as well. And then
No, she's got 5 pi 6 or 11 pi 6. 5 pi over 6, 11 pi over 6.
yeah,
But I don't
know how she got there.
Let's see. So it's sine over cosine, right?
Yeah, it is.
No, that makes sense. Okay, so tangent is sine over cosine, right? So you got 1/2 over negative radical 3 over 2. You bring the 2 over to the top, times it by 2. That becomes 2 over 2, which reduces the 1 over negative square root of 3. Or sorry, negative 1 over square root of 3.
Okay.
So that actually...
Oh, okay. Yeah. Yes. Okay. And then we just have to find where that equals where
So
was it square root of 2 over 2 divided by 1/2. So we need to find where the sine is 1/2 and the cosine is square root of 2 over 2.
Yep.
Which is at 5 pi over 6 and 11 pi over 6. Okay.
Also, maybe 5 pi over 3, but that's... No, never mind. I was wrong. Don't listen to me.
Okay.
Just those two.
Okay, perfect. Yeah, I get that. All right, number 4.
So,
Number 3. So we need to get that cosine by itself. So it's
add 3 divided by 4.
It's going to be cosine squared equals 3/4. And then you take the square root of that, and it's going to be plus or minus the square root of 3 over 2.
Mm-hmm.
And so then wherever the cosine is square root of 3
Plus
over
or
2.
minus.
So that's
Square
going to
root of 3 over 2, yeah.
be 5 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.
Okay.
Okay. And then the last one. You just break it up into 2 different ones. So it would be secant plus 1 equals 0, and then, or cosecant plus 1 equals 0, and then secant minus 2 equals 0. So then the secant equals 2, and the cosecant is negative 1. And so secant is 1 over cosine. Or wait, the cosecant is, so where the cosecant is negative 1. Well, cosecant is 1 over sine.
So cosecant is 1 over sine, but secant is 1 over cosine, right?
Yeah.
Okay.
So cosecant is 1 over sine. So 1 over negative 1, which is negative 1.
Right.
Wait. Cosecant is 1 over sine.
Mm-hmm.
And that equals 1. Sine over 1. So
Negative 1?
So if the cosecant equals negative 1, then the sine is what? 1? Negative 1. So the cosecant is negative 1, so that means that the sine has to be negative 1, which is at 3 pi over 2.
Okay.
And then the secant, if secant is 2, secant is 1 over cosine.
Mm-hmm.
And so wherever the cosine is 1 over 2, which is pi over 3 and pi over 3.
Makes sense to me.
Okay.
Actually, really quick. So to get with the secant minus 2,
Yeah.
we're gonna add 2 to both sides. So now it's secant A equal to 2, and then we're gonna change that to 1 over cosine of A.
Yeah.
Is equal to 2, and then what? How do we?
So then it's going to be 1 over 2 because the secant equals 2. I think. Oh, because secant is 1 over cosine, right?
Hold on, I cut out for a minute.
Okay, so secant is 1 over cosine, right?
Yep.
And 2 is going to be 2 over 1, right?
Okay.
And so the secant is 2 over 1. So if you want the inverse of that, which is going to be,
Oh, you cross multiply.
or you just flip it, so it'd be 1/2.
Okay. Okay, got it. No, that makes sense.
Okay. Perfect. All right, now back to, okay, and then we did number 5.
Mm-hmm.
Okay, reduction theorem. Review the materials, ensure that find each part of the reduction theorem. Let's see. So rewrite negative sine of x plus square root of 3 cosine using the reduction theorem. So what's the reduction theorem? Reduction theorem. The reduction theorem is,
So it's a sine of x plus b cosine of x is equal to square root of a squared plus b squared sine of x plus a. For
what?
any real number of x.
Okay.
I guess that's kind of handy. So what is, let's go move that over there. Back to here. It's negative sine of x plus square root 3 cosine of x. All right, now, so that is equal to radical a squared plus b squared sine
So
of x plus a.
So 2x.
So it would be radical 1 plus 3. I'm not sure if the radical, I don't know, it doesn't really say on Google reduction formula. I don't know if the radical ends at the a squared plus b squared or not.
I'm not sure.
Yeah, I can't even read good, so this is an adventure. Yeah. Yeah, and Google searching it is not helping at all. So
Should I just ask her to email us for more information on the reduction theorem?
Sure, I'd like that.
All right.
I just want to know how that works, because then it would be sine of x plus -1. And if it is separate, I wonder if it has that on the key. It does not.
Yeah, I'll just have her email us more information.
Okay. Well, I just want to know if it's radical a squared plus b squared, and then that's it for the radical. Because if that's so, then that's going to be 2 sine of x minus 1.
Yeah.
Which is honestly pretty fantastic. And it's way easier to write out than that other way. Alright, then to solve, sine 2 of x is equal to sine of x.
So I think I'm just going to have her email us about all of these because I don't think I know how to do that one either.
Yeah, I don't either.
And it kind of sucks because we're supposed to have a group of 5 people, and 5 people should be able to answer it a little bit better, you know?
Yeah. So what happened to Claire and Emily? Are they just gone with the wind?
I guess they're just MIA. Let's say. I don't know.
That's too bad.
Yeah. So, all right. So the example, based on the previous problems you have solved, what is the issue in solving this equation? Probably the tangent and the secant, right? Yep. Okay. What identity can be used that relates tangent and secant together? Isn't 1 plus cosine equals secant?
Pardon?
1 plus tangent squared equals secant squared. That's a rule.
I do not know.
Yeah, so 1 plus tangent squared equals secant squared. That's a rule. So that's how we can get them in the same equation. And what will we need to use this identity? Well, we'll need to know this. We'll need to know secant. And we need to know tangent, which we do. So we're good. So then it ends up being 1 plus tangent of 3x equals square root of 2 plus 3x, or times 3x. And then you plug it into the equation, so then it's tangent of 3x plus 1 squared. Because 1 plus tangent squared equals secant squared. So then you put secant in there, which is the square root of 2 secant 3x. You square that as well. And so now that we have it in tangent, it's going to be tangent squared 3x plus 2 tangent 3x. Oh, what the heck? Yeah. Plus 1 equals 0. So now we have tangent squared 3x minus 2 tangent 3x plus 1. We can use the quadratic equation.
I'm sorry, I disconnected again there for a minute. I'm sick and tired of this.
So it was at tangent 3x plus 1 all squared equals the square root of 2 secant 3x squared. because that puts it in the rule. Okay, and so then you have to square them both. And when you square it, it comes out as tangent squared 3x.
Plus 1
Yeah.
is equal
to
sorry.
2 tangent 3x. And then you want to get a 0 on that side, and so you subtract the 2 over. So then it's tangent squared 3x minus 2 tangent 3x plus 1 equals 0.
Oh, duh. Oops, I forgot about factoring.
Yeah. And then we can use the quadratic equation.
Well, it's tangent of 3x plus 1 squared. I don't even need to use the quadratic equation.
So now we have tangent of 3x minus 1 squared, right?
Wait, what?
In parentheses, tangent 3x minus 1, and then outside the parentheses squared.
Oh, got it.
Yeah. And then you come out with tangent 3x equals 1 because of the zero product theorem. So then it comes out as the inverse tangent of 1 equals 3x. And then the inverse tangent of 1 is at
Equal to 3x. She didn't say we couldn't use a calculator, right?
I don't think so. Let me see.
I don't know. I'm trying to do the tangent of inverse tangent 1 in my head. That just sounds painful.
Yeah, we can use a calculator.
Yeah. That's not gonna work. Tangent to the power of -1, 1. Exact value. It's pi over 4.
How did you get that?
Tangent to the power of -1 times 1.
Oh, okay. Yeah, that makes sense. So it's pi over 4, and then the inverse is 5 pi over 4. So then 3x equals pi over 4 and 5 pi over 4.
Okay.
And then you have to add pi k or 2 pi k before dividing. We'll have to add 2 pi k because we have something bigger than just pi, which is 5 pi over 4. So then it's 3x equals pi over 4 plus 2 pi k. And then when you divide the 3x, you get pi over 12 plus 2 pi k over 3.
What is the k, by the way?
I think it's just a placeholder.
Okay. I'm fine with that.
And then, so for number 5 now, we got to find the solutions from that. So, sine squared is 1 minus cosine, which is what we have on the other side. So it's going to be 6, 1 minus cosine, because 1 minus cosine equals sine squared. Or 1 minus cosine squared equals sine squared.
Okay.
And then just the same 2 cosine x.
So now they're both, cosines or whatever.
Yeah. And then I guess we just
bring the 5 over from the other side.
Yeah, and then distribute that 6 on the outside. So then it would be
6 cosine 2x. Sorry, 6 minus 6 cosine squared x.
Why would it be 6 minus 6 cosine?
Because we're distributing the 6 back in. So that way we can combine like terms and whatnot.
Oh, okay. Yeah.
So then we've got 6 minus 6 cosine squared x minus 2 cosine x minus 5, which then comes out to being 6 cosine squared x plus 2 cosine x minus 1.
Yeah, 6 cosine squared x plus 2 cosine x minus 1 equals 0. Yeah. And then
Quadratic equation. I hate this thing so much.
So then it would be negative b
Plus or minus
the square root of 4 or b squared. So 2 squared
4
minus
4 times negative 1 times 6.
over
Would be 24. So 4 plus 24 would be 28. So negative 2 plus or minus the square root of 28 over 2 times a, which should be 12. And then do math. And
so then
it's 0.2743 and 0.6076.
Yeah, 0.2743 and then 0.606. All right. And then we just have to take the inverse cosines of those. And it comes out as 1.29 and 0.9178.
Okay. My question is, why does she have 4 different answers for that on here?
It's just what I was about to ask.
All right. I'm glad we're on the same page about that, because that is some janky stuff. I do not feel prepared in the least bit.
Oh. Okay, I think I got it.
I'm back. This stupid thing broke again.
So what I'm seeing is those answers are the difference between our answer and pi. So I'm assuming that you have to take that answer and subtract it from pi.
But pi is 3.14, right?
Yeah.
So 1.29 minus pi is...
No, pi minus 1.29.
Oh. Well, that makes sense. Look at you, you smart cookie. You done figured it out.
Yes, sir. And guess what? We are done.
I'm so very grateful for that. I'm not saying that I don't like spending time with you learning math. I just...
Hey, man, we're on the same page. I got you.
Good, man. Just making sure.
Yeah, dude. So
because it's nice. Like, I like it just 2 of us, because I feel like it's a little easier to learn and go over stuff. Like, yeah, it sucks we don't have as big of a pool of resources, but I'll be honest, I feel like you know the most out of all of us. So
I would say Austin. Austin is just
yeah. Okay, well, Austin knows everything, but
yeah. Okay, well, I guess we'll just plan on meeting on Thursday again then.
All right, sounds good to me. And
All
hey,
right,
if
see ya.
you get stuck on any of the stuff, just go to the resources page. And I was just looking at the, that's where it gave me the reduction
Okay,
PowerPoint. But
okay,
then again, like, I don't know. I'm just now finding out that this is a thing. And,
okay.
there's only 3 weeks left in this semester. I'm not proud, but it
Yeah,
seems helpful.
okay, sounds good.
Awesome, dude. Take care, man.
All right, bye.